Alright, now we are going to talk about domain of a function, right? Domain of a function. So the topic that we are going to talk is domain. A function. I mean, when you check your textbook or any reference book um, for the domain of a function, they'll give you, I guess, a formal definition of what domain of a function should be. Um, but what I'd like to also point out is that domain of function is same thing as possible input value, right? Possible input value is what they call is domain of a function. They usually use x for the input value, right? If you have like f of x is something something, then this x is going to be the input value right here, right? So when you think of domain of a function, then you should think about, oh, possible input value. So let's say, example, let's say if you have f of x equal x plus 2. Now, what possible value that we can use as an input value of x? Well, that possible value is going to be the domain of this function. So, in case like this, is there any value that we cannot use as an input value of x? Is there any input value will give you trouble if you use within this function? Well, if you check this, you can see that there's really nothing. There's no problem. There's no possible x value that you cannot use in here, right? So in this case, domain is going to be all real number, right? Any real number that you can use as a domain of this function. All right. Let's do a couple of other examples to figuring out a domain of function. Okay, so example, um, find the domain of the following functions. Find the domain of the following functions. All right, let's say first one, f of x is going to be x to the fifth minus 4x to the cube plus 2x squared minus 17. Just made it up, right? Well, you can see that there's no x value that we cannot use here because nothing will give you trouble. Even though this is like x to the fifth higher order function, doesn't really matter. Domain is going to be all real numbers, right? There's no x value that will give you a trouble. The next question is typical question. Let's say f of x equal, say 3x over x minus 2. Now, what do you think about this one? Now, what possible x value that we cannot use in here or here? Think about it. So what possible x value that you cannot use in here or here? Well, here there's no problem, but here that you can see that there's one x value that you do not want to use it here, which will make this denominator equal to 0. You got that right. X shouldn't be 2. So in this case, domain is all real number, except, but, you can say, but x cannot be equal to 2, except x equal 2, or you can just say all real number, but x cannot be equal to 2, right? All right, same kind. Let's say f of x equal 10x over x squared minus 4. Now, if you have a question like this, there's really two things that you really have to be careful with this domain question. One is this fraction form, rational expression type of rational function. Another one is just one with the square root, which will come up in our next example. But let's deal with this first. Now, you want to figure out a value that will make this denominator equal to 0. You want to figure out the value that will make this denominator equal to 0. So what you need to do, first thing that you need to do, you need to put this given function in a slightly different form, factor the form. Now, how do you factor this? Now, as I said before, I'm going to assume that you know those previous chapters, the factoring chapters, so you know how to factor this like that. I'm not going to go in detail with this. If you're not sure, please go back to the factoring lecture and make sure that you understand, then you know how to factor this. Now, once you factor it like that, then you can see that there's two x value, which will give you trouble. One's from here, one's from there. That value will give denominator equal to 0, and you definitely don't want that, right? So domain is going to be, again, all real number, but except, but x cannot be equal to -2 and x cannot be equal to 2, right? These two problems. This one here, you can't have x equal to -2, which will make this equal to 0, which will at the end make the entire denominator equal to 0, right? And x cannot be equal to 2. Look at this. If you put 2 here, what will happen? 2 minus 2 equals 0. I mean, you have to put 2 there too, so it'll be 4. It doesn't really matter because that becomes 0. When you multiply, the whole thing becomes 0. You do not want that, right? So that's the answer. Now, the last of these questions would be something like this. F of x equal square root of x minus 3. Now, there's really two things that you really have to be careful. One is, with this domain type of question, one is the fraction form, the rational expression type of function, and another one is one with the square root. The deal with the square root is that anything inside must be greater than 0. That's the deal, right? X must be, whatever inside the square root must be greater than, or it can be equal to 0, but no negative. So whenever that you have something like this, you need to figure out what x value will make this less than 0, right? So this should always stay greater or equal to 0 like that. And how do you solve this? Well, you make this negative 3 to the other side, right? So that becomes x greater or equal to 3. And that's the domain. Now, most professor will take this as correct answer, right? But some professor would like to put this in a proper set form because if you think about it, how many x can you think of which is greater than 3? Well, x can be 4, x can be 5, x can be 10 million, right? X can be any number that's bigger than 3. So what they usually do is put that into the set form, and it looks like this weird format like this. So what's that supposed to mean? Well, this 2 is a set notation, and within that set we're going to have a bunch of x. That's what it means. And this bar right here is saying I'm going to tell you what this x is about right next to this bar, and that x must be greater than 3. It's kind of weird notation, but that's what they use. If you put it like this, your professor will be very happy to see the proper way of writing these things. So why don't we use it like that, right? Okay. Now the next topic that I like to discuss here is the sum, difference, and product and quotient of two functions. So now we're going to talk about adding, subtracting, multiplying, dividing between functions, right? Between functions. I mean, these are usually pretty easy. I mean, if you have two functions, you can just add it. If you have, two functions, you can subtract it, you can multiply it, you can put it in a fraction quotient form. So these are pretty straightforward. So let's just try one example in this topic. Okay, so here we go. Example. Let f and g be two functions defined as, let's say, f of x equal 1 over x plus 2 and g of x equal x over x minus 1. Okay, and the first thing that we're going to do is adding these two. So f plus g of x. I mean, it's like a weird notation, but that's how they put it like that. And this would be exactly same thing as f of x plus g of x. I mean, that's obvious, right? You're just adding these two together. So this would be same thing as f of x, which is x plus 2. I'm just writing this part, plus what's g of x? Well, x over x minus 1, just like that. Now all we need to do is just adding these two together. And as you can see, you notice that these two have different denominators. So how do we How do we deal with something like this? Well, you have to make a common denominator. So to this, we are going to multiply this. So to this, we're going to multiply x minus 1, top and the bottom, of course, right? And to this, you're going to multiply the other part, which is x plus 2, like this. Of course, the top and the bottom, right? So this yellow part, the greenish yellow part, was the original, and this red part was what we added, right, to make it a common denominator. Now, if we do that, then now we have the common denominator, which is x minus 1, x plus 2, like this. And I'm going to put this one in here. Well, this is just x minus 1 plus 1, so it'll be just x minus 1. I mean, did I say plus? It should be times, right? X minus 1 times 1. No change. What about here? Well, this has to multiply in here and here, so it'll be x squared plus 2x. Now, all we need to do is just simplify this just one more steps. So our denominator is x minus 1, x plus 2, and let's write this x squared first. I'd like to cross it out just to, avoid any confusion. We have x and 2x, so that should be 3x, and now we have just minus 1, just like that. Well, we are almost done. We just have to add x cannot be equal to 1 from here, and x cannot be equal to -2 from here. These two x value will make this denominator equal to 0, right? Now, as you watching these video clips, it's always good idea to pause several times. You need time to digest this. So you pause here and there and see if you can understand this and see if you have any question at all. And if you have question, you can go back to the textbook or go back to the previous chapters and try to understand this this as a whole concept, rather than just segmented a small chapter. You really need to understand this whole thing, because if you need to do this, you really have to not only understand the function, but you really have to understand polynomial equations and how to add, and how to factor and how to multiply and all these other things. So you should really try to understand this as a whole bit. Okay, now the second part would be function f minus g of x. Well, as you guessed, this would be almost the same thing. So this would be f of x minus g of x. I mean, this is exactly same as this, except this part now, this time this is going to be the negative. The setup and everything is going to be exactly same as this. Now, because this is minus here, that's going to be minus there. So this was 1 x plus 2 minus, this time, x over x minus 1, like this. And of course, since we need common denominator, to this we're going to multiply x minus 1 x minus 1 top and the bottom like that, and to this we're going to multiply x plus 2, just like what we did in here. And if we, now that we have common denominator, which is x minus 1, x plus 2, I'm going to simplify this. We just have to be a little bit more careful because this is minus there. The first part, however, nothing really different. Now it's going to be minus, and let's put this in the parentheses, so it'll be x squared plus 2x, just like that. Now, because that's a minus now, this will be simplified as x minus 1. This would be x plus 2. Now, because that's a minus, this is going to be minus x squared, which doesn't have any like terms. I'm going to write it first. And that's going to be minus 2x, right? Because of that minus there. Now we have x minus 2x. It's going to be minus x. All right. And we have minus 1 like that. So I guess you can leave it like that. You know, I don't see any problem leaving like this. Or if this, you know, it's kind of difficult to write a straight line in here. Let me try again. Okay, that's a little better. Since we have minus, 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 and that if that bothers you, you can factor out the minus like that and put it like this, plus, plus, plus. And this is going to be x minus 1, x plus 2, and of course we need that condition. X cannot be equal to 1, x cannot be equal to negative 2. Right, just like this condition right here. So this is good answer. That's a good answer too. And you need to add this. All right, you need to add this. All right. C. Now we are going to do multiplication. Multiplication is f times g of x, so it'll be just f of x times g of x. This is very easy, much easier than addition or subtraction. Because what's f of x? It's 1 over x plus 2. What's g of x? X over x minus 1. So how do we multiply it? You multiply top together, you multiply bottom together. So this would be 1 times x, it's just x. This you don't have to expand, you just x plus 2 times x minus 1, and that's it. That's the final answer. How easy is that? And of course, you have to say x cannot be equal to negative 2, x cannot be equal to 1. Right? We don't want any one of those denominator goes to 0. Right? So easier, right? Okay. D is quotient. So f over g of x. Now, this is same thing as f of x over g of x. So what was f of x? It's 1 over x plus 2. Now what's g of x? X over x minus 1. All right. So, I mean, this is also not that bad. When you have fraction over fraction, the trick is you put this right here, x plus 2, and then you're going to put this bottom part right here and make it as multiplication, but you have to flip this top and the bottom. So this is become x minus 1 over x. Now notice that this has been flipped here, right? So if you have fraction over fraction, this is how you do it. So you can just simplify this as multiply 1 times x over 1. It's just x minus 1 is just x minus 1. This times this would be x times x plus 2. Just like that. And of course, you have to say what value of x will make denominator equal to 0. Now, if you just check the last result, then x cannot be equal to 0, which will make this equal to 0. X cannot be equal to negative 2, which will make this equal to 0. But not just this, but you have to see the whole thing. Any denominator will make any part of this solution equal to 0, any denominator, then we don't want that x value. So let's look at right here. X cannot be equal to 1. Because if x equal 1, you cannot get to here. It'll blow up right about here, right? So you have to have all three conditions, just like that. All right.